Integrating Linguistic and Developmental Perspectives, written by Julian Musolino in 2003. The article brings together two independent lines of research on numerically quantified expressions. One comes from the working linguistic theory and asks which is the real meaning of numbers, and the other comes from the study of language development and asks when and how children learn the meaning of such expressions. The goal of this article is to show that the two theories at the same time can limit and enrich each other. The work in linguistic theory wants to show that the expression n can't be understood just as exactly n, but also at least n and at most n. And the interpretation depends on the context in which these words are used. If we check the first three examples, the first is an example of exactly 3. How many mistakes did you make? I made 3 mistakes. And this means exactly 3, not more, not less. The second is an example of the at least meaning. Do you need to make 3 mistakes to be allowed to take the test again? Which means that also 4, 5, 6, and so on mistakes would also allow you to take the test again. And the last example is you can make 3 mistakes and still pass the test. This is an example of at most, which means that 0, 1, or 2 mistakes will still let you pass the test. The goal of the experiments presented in the article was to demonstrate that 5-year-old children have the knowledge that n can be understood also as at least or at most n, but they don't have the exact, they don't know the exact meaning of that. Specifically, the author asks when and how children learn the numerically quantified expressions, and when do they receive this non-exact interpretation, or when can they give this non-exact interpretation. Using the tools of experimental psychology, the author shows then how these questions can be addressed experimentally, and the result from such experimentation can be used to explore theoretical analysis of the semantics of numerals. So the article presents 3 experiments, but I will present the first one more specifically, because otherwise it's a bit too long. So the first experiment had 2 goals: to test English-speaking adults and English-speaking 5-year-old children. How do they interpret these numerically quantified? The tested children, 12 girls and 8 boys, were old between 4.3 years and 5.11, and they were all recruited in a preschool in Bloomington. Some of them, or 5 of them, had to be replaced because they were too shy or because they couldn't provide any justification to their answers. The adults were also native speakers of English, but they were all undergraduate students at Indiana University. The experiment was held using the true value judgment task methodology, which involves 2 experimenters. The first experimenter acts short stories using small toys, and the second plays the role of a puppet who watches the stories alongside the subjects. At the end of the story, the puppet makes a statement about what he thinks happened in the story, and the subject's role is to determine whether the puppet statement is right or wrong. And these subjects are asked to provide justification for their answers. For this experiment, the experimenters told some different stories, and you can see these stories in the examples. But I will present just one of them, the one which was also presented in the article. So for the at least conditions, subjects were tested on statements like Goofy said that the troll had to put 2 hoops on the pole in order to win the coin. Does the troll win the coin? If we check the picture of the situation, we see that there are 4 hoops on the pole, and if 2 is meant as at least 2, the answer is yes, and the troll wins the coin. But if we have to interpret it like exactly 2 hoops, then the answer should be no, since there are more than 2 hoops on the pool. And the same was with the opposite. For at most, they selected sentences like Goofy said the troll could miss 2 hoops and still win the coin. Does the troll win the coin? And it's wants to check the opposite. If we check once more the picture, we can see that the troll missed just 1 hoop because there are 4 hoops on the pole. And if we interpreted this at most 2 hoops, then the troll should win the coin. But on the other hand, if we interpret this as exactly 2 hoops, the troll doesn't win because the number of missed hoops is different from 2. So let's see now the results. The results say that adults accepted the puppet's statement 95% of the time in the at least condition, and 97.5% of the time in the at most condition. By contrast, children accepted the puppet statement 82.5% of the time at the at most condition, but less often in the at least condition, which was just in the 35% of the time. The 5% of the answers that were negative in at least with adults came from the subject who 2 times explained that the character in question shouldn't win because he was invoking the fact of the exact interpretation of the numbers. And turning to children's justification, we find the same interpretation. They also said that the character shouldn't win because the number is not exactly the same. But mostly children gave interpretations like the troll had to get 2 hoops on the pole and he got 4, so he wins. And this was for the positive or for the at least. When children decided that the main character shouldn't win, they always invoked the fact of exact interpretation of the number that was false. But as I said, they all gave an appropriate justification in both of the cases. All the tested subjects interpreted the at least examples as exact, and this means that children can't understand the non-exact meaning of numbers so easily comparing to adults. This can mean that children and adults implement their grammatical knowledge differently. This can also be caused from their competence and performance, or the difference between them. And why this happens was shown in the other 2 experiments. The second experiment was about lending and borrowing stuff from a puppet. And the third experiment was something about some cards that children had, like these cards had some faces or number of objects, and children had to decide whether to keep these cards or give them away. Yeah, comparing to the questions that they were asked. Just a second. So the purpose of the study was, as said, bring together theoretical and developmental perspectives on numerally quantified NPs, and to show that when integrated, these perspectives inform each other. The main finding is that by the age of 5, children have implicit knowledge of the fact that such expressions can receive non-exact interpretation, but in certain contexts, while they do not know yet the meaning of corresponding expressions, such as at least and at most, which convey this sense explicitly. But the experiment shown that although preschooler semantic competence does not differ from the adults one, children's ability to implement their knowledge is nevertheless just more fragile. And this is everything.
Okay, thanks a lot. Very, very clear, very nice presentation. However, I would mention a little bit the results of the second experiment, right? Because you sort of discussed the conclusion of the paper, right? But from the first experiment, we cannot really draw those conclusions, right? So the first experiment was showing that actually children were kind of were behaving differently from adults, right? Because they were, like, paradoxically, they were adopting more exact responses in a context where the at least response would have been more appropriate, right? So do you do you remember what kind of changes they said they made from the first to the second experiment?
I have to check it once more.
Yeah, so I opened the paper here. So if
okay, so I stopped the presentation.
I can share this one. Yeah, so right. So can you see that? Can you see the paper?
Yes.
Yeah.
Okay, right. So yeah, so basically, just you know, one very little thing that I want to add is that basically they run a second experiment where they claim that they made the context more felicitous, and they prime the saliency of the at least reading. So they had this sort of helping thing, right? So they said, okay, let's see if Goofy can help the troll. The troll needs 2 cookies. Does Goofy have 2 cookies? So they sort of highlighted this kind of context of need. So this was kind of the setup, right? So they said, okay, let's see if Goofy can help the troll needs 2 cookies. Does Goofy have 2 cookies? And also they put 2 here in a question. And, you know, questions are a specific semantic environment. So for some reason, they might actually facilitate this sort of weaker interpretation of scalar terms, if we want to think of numerals as scalar terms. And then what happened is that the children who accepted Papa's statements only 30% of time in the first experiment, they actually did it at 80% of time in the second experiment. So this is a table basically that shows that the adults did not really differ their performance, whereas the children went from 30 to 80% of at least interpretation, right? So yeah, the conclusion was exactly what Neza said, that they claim that that basically children's competence with respect to numerals interpretation is the same as adults one, and they're perfectly competent in adopting the at least, at most, and exact interpretation, right? Although if you think that numerals are strengthened via scalar implicature, it is still quite puzzling to notice that in the data that you presented, they actually had more exact interpretation than adults. So this clearly showed that with numerals, there is something going on. We cannot draw a complete parallel with respect to other scalar items like sum, right? So a lot of people claim that actually numerals are somehow ambiguous among these three readings. So maybe lexically ambiguous, or maybe you have additional semantic and pragmatic operation that basically shape their interpretation. So one other possibility is that numerals start exact, and then instead of deriving their exact interpretation via pragmatic inference, you derive the at least interpretation via some sort of pragmatic inference, basically. So some people propose like a sort of a pragmatic existential operator, like Brihinius in 2008. And then, okay, you know, it's this kind of can generate, you know, a lot of sort of problems, because then if numerals are always exact, then you're wondering how is it possible then that people can get this at least interpretation even in context in which it does not seem to happen some strange sort of pragmatic widening or pragmatic weakening. Okay. The other puzzling thing would be that if you claim that numerals get the at least interpretation via some sort of pragmatic operation, then it is strange, because usually pragmatic leads to strengthening, right? Whereas if you go from an exact meaning to an at least meaning, you're actually weakening the meaning of numerals, unless the numeral occurs in certain specific contexts. So you might also think that context, like the context of need, right? If you say I need two cookies and then I'm going to be happy, right? And you give me 3 cookies and then I ask you, okay, am I going to be happy? And you say yes, because you actually needed 2 cookies. I gave you 3, so you're going to be more than happy. We might think that this kind of context of need, in a way, they contain a sort of a hidden conditional, or a hidden sort of logical structure that resembles a sort of a downward monotonicity of a conditional. So, you know, you might spell that out by saying that the context of need would say that I need at least 2 cookies to be happy. And so 2 cookies would represent the minimal sufficient amount of cookies to make me happy, which means that if I get 3 or more, then I'm going to be happy as well. So you might think about these things, that the context actually includes some sort of some sort of conditional structure, or you know, some sort of pragmatics or semantics that is completely opposite to the one of some standard declarative context. Okay. Right. So yeah, still more puzzling data, more results, and nowadays we haven't really reached a conclusion about how these things work. Okay, so thanks a lot. And so I guess we don't have any other presentations for today, but we are going to have a lot of presentations next time. So probably I should tell you the end of the story of our research on implicatures and indirect implicatures, and present you some data that we did on a control experiment on direct scalar implicatures with the same paradigm that I showed you yesterday about the indirect implicator experiment. Okay.
Can I just ask something before we move on?
Please, sure.
Okay, thank you. So while listening to the presentation, I was wondering, do you know when children become proficient with modal operators? Because like, at least in the first experiment and even in the second one, everything hinges on the modal environment to facilitate the at least or at most reading, right? Mm-hmm. And I was wondering if some of the variance might be explained by children not being proficient with modals.
Yeah, so how old were these children?
between 4 to 5, right?
Between 4 and 5, so
Yeah.
quite young, right?
Yeah, just in the last experiment, they were a bit older, I think from 5 to 6,
4.5 and 6.
because they realized that from 4 to 5, they are not old enough.
So what do you mean by modelized context?
Well, so if you have these utterances, Goofy needs 2 cookies, right? Like need is modal, and then in the other one we have can, right? You can make 3 mistakes. So without this, you just have an exact meaning for the number terms.
Yeah, I mean, I guess what they would say is that given that in the last experiment with the need model, then actually they did it right, or they did much better. So they would probably claim that actually they command the meaning of need, right? Which probably would be reasonable given that it's a very high frequent verb and it's been used a lot in child language. And I would expect by 4 and 5 years that they actually at least they're familiar with this kind of verbs. But yeah, you're right. Maybe in the first experiment, this was not explicit enough, right?
So I'm not questioning the results. I think they're actually quite clear. But I just think that maybe that should have been mentioned, but I don't know enough about modals, at least in terms of language acquisition, to judge this. So.
Yeah, I mean, I if you remember, we discussed the paper by Moscati and Gualmini, right? And that was all about modal and implicators and modals. And there again, it seemed that they kind of knew the meaning of the model, right? But then it was about how to restrict that interpretation, how to derive implication.
Right.
So I mean, I guess by the age of 5, I guess that negation quantifiers and basic models are supposed to be at least partly acquired and at least successfully used and also produced, right?
Okay.
But then again, of course, you might say, okay, maybe they learn the basic semantics of these items, but they still have to learn how to use that, right, in a concrete communication situation. And other people will say, yes, they actually know they have a complete competence of the use of these logical operators. What I struggle with is to to understand the pragmatics of the experimental context if the experiment is not well designed, basically.
Right.
So if you don't highlight certain features of the context that would make this reading salient, right? Yeah, but yeah, I mean, it's on the mark, yeah. So right. So for instance, they quote Gelman and Mack that say that theories of cognitive development must distinguish between implicit principle of knowledge and skills that derive from and are related to these principles. It will not do to base accounts on knowledge on a requirement that skills would reflect the knowledge be executed without error. Errors due to performance demands are to be expected, right? And this is cool because, when I presented my experiments on numerals that we're not going to have time to discuss, I got a lot of questions by Jeff Leeds saying, okay, why did you exclude so many participants? Why did your participant didn't understand the task? Why did you exclude, because we had this kind of threshold that if they would not pass certain control tasks, then we would not consider the experimental items, right? And he was really, really obsessed about the fact that we excluded like 13 out of, 45 participants. And maybe I should have quoted exactly this passage, right? That, sometimes people are if there are errors committed by their participant, they say, yeah, your experimental task is shit, it's bullshit, it's not working. But then, it's kind of tricky, especially these kind of inferences are very, very, very difficult to to test specifically, and see if someone fails, you don't really know what is the reason why this person fails, right?
Right.
So yeah, but I mean, if yeah, I mean, if there is anything to you know, there's a strong result coming out of this experiment, is that if you had a very, very simple theory that would say numerals are strengthened via implicatures, children do not derive implicatures, therefore they should be led to interpret numerals with the at least interpretation more often, and the first experiment clearly shows that the opposite thing is going on. So at least a simple model saying that numerals are purely strengthened via implicature and children derive less implicature would not hold, right? And, you know, recent evidence is kind of showing that this simplification would just be inaccurate, because children can derive implicatures if they have the right context. And also with numerals, they do strange things, just like adults. Okay, cool. Nice. All right. So if there are not other questions or comments, I would take like a 5 minutes break. And then I would tell the end of the story of our research, basically. And then, yeah, and then we're happy. Okay. So see you in like 5 minutes. Okay. So let me share the screen. Nice. Okay. So yeah, there's been a change in the program. So now we are going to talk about the acquisition of numerals, and I'm going to say this again for the people who are not attending today's class and we watch this video. There will be another video that I uploaded about the other experimental implicatures. All right, so where do we start? Should I just present our experiment or introduce a little bit about numerals acquisition? Yeah, maybe a few things. Okay, so you can see the slides, right? So one of the things that people were sort of interested and puzzled about is the way children acquire numerals from the very first early stages, okay? And how they map numerals representation or quantifier representation onto non-linguistic representation, and how to deal with this kind of ambiguity that numerals generated, okay? So, right, so one of the facts that we know is that children acquire numerals in distinct stages. So, for instance, at the very beginning, the one knowers, basically, they enter into the stage of one knowers, so they know the meaning of one, but they don't know the meaning of 2, 3, and higher numerals. And then they become two knowers, so they know the meaning of 2 and 1, but not the higher numerals. And then they become 3 knowers, so they know the meaning of 1 and 2 and 3, but not 4. And then they become 4 knowers, and kind of at the same time, they become cardinal principal knowers. And from that time, they can recite all the numbers they want, basically, okay? They know the meaning of any number they can recite. So, right, so in the old experiments, there was, for instance, the given number task that was quite famous. So children were shown a set of fish, and they were asked to put a subset of this set into a container, like put 2 fish into the fish pond, right? Can you put 1 fish into the fish pond? Can you put 2 fish in the fish pond, and so on? And the methodology of this experiment was called a titration method. So you would ask a child, can you take 1 fish and put it in the pond? Can you count and make sure that that's exactly 2? And if they put the wrong number of fish, the experimenter would say, but I wanted this number of fish. I wanted 2 fish. Can you fix it so that there are 2 fish? So basically, the number at which children were successful at giving that number of fish, would trigger basically the move to the next higher number. And if children fail the higher number, they would go back to the previous number, right? And the test goes on until they fail two-thirds. They fail the trial in two-thirds of times. And so at that point, they would be classified as n knower. Okay, so if they manage to put 2 fish in the pond, but they would fail to put 3 fish, and then they would succeed in put 2 fish, they would be 2 knowers. Okay, so right. So one of the interesting things about this is that, for instance, in Barner and Bachrach study, which probably, no, I think someone is going to present Brooks. So we're going to present some of these experiments, but not exactly this study. Anyways, what they notice is that, that for instance, so they think that children might actually learn how numerals work. So they might actually learn the exact number of numerals via scalar reasoning. So they say, there might be one reason why 1 knowers know the meaning of 1 and not the meaning of 2, and 2 knowers know the meaning of 2 and 1, but not 3. And the reason is that they use higher numerals to restrict the meaning of lower numerals via scalar implicature. So 1 means 1, but not 2 or more, okay? Which doesn't mean, it doesn't imply necessarily that they would do this all the time once they acquire the system, but maybe this process would help them highlight the idea that numerals have an exact numerosity, denote an exact numerosity. So what they, what they observed by reviewing the existing literature is that, for instance, in this task that I showed you, in the given number task, n knowers, so let's say 2 knowers, for instance, would frequently give n plus 1 object, so 3 objects when asked for 3, but they would also give 3 objects when asked for higher numbers, okay? So for instance, 1 knowers would give 2 fish when asked for 2, but also 2 fish when asked for 3, okay? So they analyze the number of errors that they make, and so they claim that, for instance, someone, a 1 knower behaving like this would not be categorized as a 2 knower, right? Because it would give 2 fish also when asked for 3. So by this criterion, it could not be a 2 knower. But actually, if you look closely, when he or she is asked for 2, she actually provides the right number of objects. So their idea is that 1 knowers already know something more about 2, but they are not able to use the number 2 when asked for 3, basically. And and also if you look at the pattern of errors, n plus 1 answers are not randomly distributed, okay? So if you look at 1 knowers, they have a lot of n plus 1 answer. 2 knowers, they have a lot of n plus 1 answers. And overall, this is different from chance. So, so across the studies, n knowers give the correct amount for n plus 1 almost in half of the times, okay? And this is statistically different from chance. So if you want to see so chance would be 7% or 12%, but they actually do it at 47%. So they conclude that actually n plus 1 is treated differently from higher numerals. And then they also, they discuss this other task, and they kind of find the same result. So this is a Watson discard test So here children have to say how many objects are on the card rather than providing the number of objects, okay? But the direction is quite similar. So then again, they analyze the number of answers and, for instance, get a 2 nowhere, right? This is the number, right? So this is the children response, and this is the set size of the numeral that was on the card. And you see that 2 nowheres are quite good with 3, and even with 4. Which means that sometimes they provide the correct answer when there are 3 objects, but then again, they say 3 even with higher numerals. And the same for 3 and 4 nowheres, they are actually quite good with 5, right? This means that they provide a 5 response when there are 5 objects, okay? So again, they're right. So again, a possible explanation is that they are on their way to acquire the successful numeral, right? But also, so their claim is that actually they might entertain a scalar reasoning. So their proposal is that actually 1 nowheres know the meaning of 2, which is why they behave better with 2 as compared to 3, right? And the idea is that they know 1 nowheres even know the meaning of 2, so they can use 2 to restrict the exact meaning of 1, but they do not know the meaning of 3, so they cannot use 3 to restrict the meaning of 2, which is why they sort of treat 2 as an unbounded quantifier, meaning something, you know, an indeterminate quantity of 2 or more, okay? So you see again this reasoning. These are 1 nowheres. They're supposed to know only 1, but they actually use 2 to restrict the meaning of 1, right? But they cannot use 3 to restrict the meaning of 2. Hence, they're not perfect in their use of 2, okay? So again, 2 fish for them means at least 2, and 3, by principle of contrast, by inferring that 3 must mean something different from 2, but they don't know exactly what it means, they sort of interpret 3 as some cardinality higher than 2. So some sort of unbounded quantifier, okay? And that cannot be used to strengthen 2, hence they cannot behave perfectly with 2, okay? So this is an interesting idea. And right, so, you know, we're not sure whether this is true or not, also because of the results that Neza just showed us, right? So it's not so clear how this 4 or 5 year old, although 4 or 5 year old are already CP nowhere, so they're supposed to know perfectly this kind of system, right? But still, if they still use scalar implicators, they would not predict it to behave like that, unless additional assumption about the structure of the context, like for instance, modalized or whatever, are made, okay? Good, so, right, so the idea is that still we observe some effects that gives us some hint about the use of some sort of scalar reasoning to facilitate the acquisition of numerals. And also we know that the interpretation process of numerals and scalar quantifiers kind of displays a strong, you know, an interesting parallelism in adults, okay? Or should, if these guys were right, okay? And yeah, we have seen these experiments already, right? And we have seen that actually numerals differ from scalar quantifiers. So again, in the critical trial, can you give me the box where Cookie Monster has some of the cookies? Children would be completely fine with the box where Cookie Monster had all of the cookies, right? But yeah, so you remember these results. But with numerals, when you ask children and adults to give you 2 fish, they would choose the cover box. They would not choose the box with 3 fish, okay? So they would not say, okay, 2 might mean at least 2, this set of 3 fish, in fact, includes 2 fish and blah, blah, blah. So puzzle, okay? Whereas with some, they have a different behavior. Okay, so it seems that numerals have an exact semantics. And so these results suggest that actually numerals are not subject to scalar strengthening, right? And yeah, and there was this other experiment that we haven't really talked about, but someone is going to present it, I think, on the last day, so we skip it. So let's get to today's study, right? So so if it is true that numerals have an exact semantics, there's no straightforward parallelism between numerals and scalar quantifiers, right? And numerals should be always considered as exact by adults and children, whereas some is strengthened more often by adults. So the question is, again, can children access the at least reading? And we have seen from this experiment by Musolino that actually they can, at least at 4 or 5 years of age. But then another question that we asked is whether the interpretation of numerals is sensitive to logical entailment properties, just like scalar quantifiers, okay? So, I will explain you what this means in a second. So this was the goal of the experiment that I'm going to talk about today. So, right. So, so this was the setup, okay? So let's say that we have these 3 boys here. Let me enter full screen. Okay. So let's say we have 3 boys in our universe, okay? And these 3 boys here go catching some butterflies. And let's say that this boy here got a 1 butterfly, and this boy here got 3 butterflies, and this boy here didn't get anything, okay? And then I ask you, did any of these boys manage to catch 2 butterflies? What would you answer? Yes or no? Anyone? I think I don't see the chat like always. No, Eva says no.
I think it's
Eva
yes.
None of these boys managed to catch 2 butterflies. Alexandra says yes. Which boy, Alexandra? I guess the one on the right, right? Yasu says yes. So you see, it's quite ambiguous, yes. Now Eva is changing her mind. Right. I mean, I don't want to force you to interpret things in the way that I want to, right? So it's good if you notice that there is ambiguity, and it's also good if you notice that actually, this guy actually, you might interpret this in Yasu's way, right? And you might say, yes, 2 is kind of including 3, right? If you is entailed by 3, right? So if you catch 3 butterflies, it logically follows that you catch 2 butterflies, right? But not if you catch exactly 2 butterflies. So you see the tree, right? So you might answer this question by saying, yes, this boy caught 2 butterflies. In fact, he caught 3, right? And now you are assuming that what Gergana is saying holds. But you might well answer like Eva. You might say, no, this boy didn't catch 2 butterflies. He caught 3, right? So you see, you appreciate this ambiguity, which is kind of cool. And, I just proved with our chat that this is actually a real thing. So how does the interpretation of numerals work? Well, you might have this at least reading. So at least 2 is actually compatible with greater quantities, right? And you might also have the exact interpretation, which exclude greater quantities from the denotation of the numeral. And just like Gergana said, you know that when you have these kind of scales, these logical scales, then you have some entailment operations, entailment relationship going on, right? In particular, we care about the logical entailment, so now you should be expert about this. This means A entails B, or if A is true, then B is true. And this means that A is logically stronger than B, which adds a little bit to this simple entailment, and it turns into an asymmetrical entailment. So A entails B, but B critically does not entail A, okay? Right. So the rule of thumb is that what is true in fewer circumstances is logically stronger. And this is one of the first things that I taught you when we were comparing different scope configurations, right? Now we just play the same game again. So let's play this game. If I tell you the boy brought a butterfly, and if I tell you the boy brought an insect, which of these two sentences is logically stronger than the other? I mean, it's kind of written in the example, but I would like you to tell me. A, right? The one on the left. If it is true that the boy brought a butterfly, it is also true that the boy brought an insect, right? So this is a typical upward entailing inference from a subset to a superset, or from a more specific to a less specific, because butterfly is an insect. It's a kind of an insect. All right. So what you might not know, and what we haven't really talked about, is that the exactly two interpretation is logically stronger than the at least two interpretation, okay? So this is different from saying that 2 is entailed by 3. Now we are taking an additional step. Now we are saying, let's compare the exact and the at least interpretations and with the same numerals, and let's notice that the exactly 2 interpretation is stronger than the at least 2 interpretation. You might say this is not surprising, because we might get this as a scalar implicature, and we know the scalar implicature gives you a logically stronger meaning, right? But let's see how this works. But first of all, let's also consider this kind of contexts, which are conditionals, for instance, conditional antecedent, okay? So these kind of contexts are called downward entailing. Why? Because unlike affirmative sentences that license inferences from set to proper supersets, they give rise to the opposite pattern of inferencing, that is licensing inferences to proper subsets. So let's take an example. If I tell you, if the boy brought an insect, he is happy, okay? And I tell you, if the boy brought a butterfly, he's happy, okay? Which sentence entails which? So this is not as simple as the previous one, right? But so you might reason in term of rules, right? So if I tell you a rule that, you know, this boy here really loves insects, okay? So anytime that he manages to catch an insect, he's like super happy, okay? Now, would you think that it is also true that if this boy brought a butterfly, he's gonna be happy? Yes or no? Yes, okay? Now, you might think this is exactly the same example as before, but in fact, it's not. It's exactly the opposite example. So before, we were considering that the sentence, the boy brought a butterfly, entails a less specific sentence, the boy brought an insect. But now we are doing exactly the opposite thing. now we are considering that when we put the insect in the antecedent of conditional, right, gives us a meaning. If the boy brought an insect, he's going to be happy, which entails the same sentence where we put a more specific term, butterfly. So you see, now the insect is on the left and the butterfly is on the right, and your inference goes to the less specific, from the less specific to the more specific. And this is a typical downward entailing inference. Okay? Now, the interesting thing is that numerals behave exactly the same. So under a conditional, at least 2 is logically stronger than exactly 2. Okay? And this is a little bit more tricky to see, but I will try to show this to you. So bear with me. Let's consider this sentence. The boy caught at least 2 butterflies and he got a coin. Okay? This sounds like I'm not really sure about the number of butterflies that the boy caught, but I think, I caught at least 2 and he got a coin. And now let's take these 4 possible situations. Okay? And now I'm going to ask you, in which situation is this sentence true? The boy caught at least 2 butterflies and he got a coin. Is it true in this situation on the upper left quadrant? Yes. Is it true in this situation here, where he caught 3 butterflies? Yes. Is it true in this situation here? No, right? What about this one? No. Good. Trivially, because he didn't get a coin, this is a conjunction. Both of the conjuncts must be true. But critically, in this situation, it is true because 3 butterflies satisfies the meaning of at least 2 butterflies. Trivial, fine. Cool. Now let's take the exactly 2 meaning and let's play the same trick. Is it true here? Is it true in this context? The boy caught exactly 2 butterflies and he got a coin. Yes. Right. What about this context? Is it true that he got exactly 2 butterflies and he got a coin? No, right? And no, and no. So you see that just by comparing these 2 examples, right, we see that this sentence is logically stronger because it is true in a more restricted set of circumstances, a narrower set of circumstances. And we know that when a sentence is true in fewer words, it's logically stronger, because if you know that you are in this situation, then you can safely move to at least 2 and you're gonna land in a true world. Okay? Same trick as last time. Cool. That's, yeah. So, and also, if you know that this sentence is true, you know that this sentence will also be true, right? Because here, for instance, this is false and this is true, so you know that you cannot make this move. Okay. So, whereas if we were in the situation where you don't have this butterfly and then you have exactly 2 butterflies and 1 coin, this is really true, right? So the important thing is that something that entails something else does not lead you to falsity when you start from truth. Okay, so now let's move to the conditional. The sentence now is, if the boy catches at least 2 butterflies, he will get a coin, okay? So this is the sentence and this is what happened. And I tell you, does this situation makes this sort of sentence as a valid rule, as a valid statement? So let's start with this. If the boy catches at least 2 butterflies, he'll get a coin. Does this make the sentence true? He caught 2 butterflies, he got a coin. Yes. Cool. What about this one? Does this make the sentence true? Yes. Good. what about this one? Does it make the sentence true? He caught 2 butterflies and got no coin. And I tell you that if he catches at least 2 butterflies, he'll get a coin. No, right? It's a typical violation of a conditional because the antecedent is true, but the consequent is false. And when the antecedent is true and the consequent is false, the conditional is false. It's actually the only case in which the conditional is false. Right. What about this one? Again, same thing, right? 3 satisfies at least 2, so the antecedent is true, the consequent is false. Bad, false. This conditional is true in these situations. In fact, in any situation in which the boy caught a higher number of butterflies and got a coin. Cool. Now, let's make the same trick with exactly 2. And now things start getting a little bit tricky. So, what about this situation? He caught exactly 2 butterflies and he will get a coin. Yes. Do we all agree? Okay. Now, what about this situation? The sentence is, if the boy catches exactly 2 butterflies, he'll get a coin. He caught 3 butterflies and he still got a coin. So in this case, the antecedent is false and the consequent is true. And Alexandra says true and Eva says false. So what's going on here? This is tricky, right? And the reason why this is tricky is that here our intuition kind of departs a little bit from first order logic. So in first order logic, oh, right. So also Alexandra is not convinced about this, right? So the real answer is that nothing can be said, okay? So when the antecedent of a conditional is false, the truth is that you cannot really say anything about the consequent, because a conditional, anytime that the antecedent is false, the whole conditional is true. Okay? This is counterintuitive because the way we use conditions in everyday's communication is by strengthening them to a biconditional. So if I tell you, if you wash my car, I'll give you $5. We kind of infer that if you don't wash my car, there is no way I'm going to give you $5, right? But you can show quite easily that conditional are not always like this by adding an even if, okay? So if you say, if I eat pizza now, I'm going to be happy. But even if I eat a burger, I'm going to be happy. So by adding, even if I eat a burger, suggests that if I don't eat pizza, but eat a burger, I will still be happy, okay? So that is compatible with the antecedent of the other conditional being false and the whole conditional being true. So trust me, when the antecedent is false and you take a conditional as a rule, you cannot really say anything about the consequent. So this is actually logically true, right? Did you understand this? I know it's a little bit tricky, but it's first order logic. So take it as a as an axiom. Good. So yeah. So now let's move at this case, right? This is easy because here he got exactly 2 butterflies and he didn't get a coin. So again, antecedent true, conditional antecedent true, consequent false, conditional false. And what about this guy? Well, this is exactly the same situation as here because the antecedent is false and nothing can be said. Logically speaking, this is true, okay? Now, if you don't like this idea that of conditional being true, bear with this more intuitive notion of nothing can be said, because this tells you that you cannot consider this false. And I told you that we consider things logically stronger when they manage to let you rule out context in which things are false, okay? So something that tells you nothing can be said gives you the idea of something being less logically strong, okay? Now, let's compare this critical case where the boy had 3 butterflies, but no coin, okay? This context makes the at least 2 meaning under the conditional false, okay? Sorry, it makes the conditional with the numeral with the at least 2 meaning in the antecedent false. But if you take the exactly 2 meaning in the antecedent conditional, the whole conditional will be true. Which suggests that this sentence is logically stronger than this one. Again, for the same trick, because if you are in a false situation when you're evaluating the sentence, then you know that you cannot move to this situation, right? So if you take the at least 2, right? You know that these are the only 2 contexts in which you are allowed to compare this to the exactly 2 meaning. These are the only 2 contexts in which if you move from evaluating this sentence to evaluating the other sentence, you are gonna land in a good situation, which is actually this, and this as well, because this is actually logically true, okay? What you don't wanna do is to go from a context in which this is false, because then you don't know if you're gonna land in a false or in a true context, okay? So take this from the opposite perspective. Let's say that we want to see whether this is logically stronger than the other, and we take this context in which the conditional is true, then we land on the other context and we land on a false. And this is bad. We don't want to do that because that would not preserve the truth of the original sentence, okay? So again, the same trick. And this all to say that we get this paradoxical effect that when we use a weaker interpretation in a downward entailing context, that actually becomes stronger. And when we use a strong expression in a downward entailing context, that becomes weaker, okay? Now, before proceeding, I want to ask you, does this remind you of anything we talked about a lot, especially yesterday? I really want an answer now, and I will not go on until I get an answer, either true or false. This idea about certain context changing the logical relationship between scalar items, does remind you of anything? This idea of stronger items becoming weaker and weaker items becoming stronger? Anyone? Any wild guess? Do you want a hint? So, do you remember what happened with all under negation? Anyone? 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 I'm looking at the chat. You can also say no, huh? You can also say that you don't remember. It's it's okay. These are difficult things. These are complex notions, and we brought a lot of stuff on the plate. Brain is fried. Okay, it's okay. I mean, it's completely fine. So I'm just gonna remind you that when you derive indirect implicators, right, like not all suggests some, you actually turn all, which was a strong item in the positive scale, right? Because all entails some. When you apply negation to all, you turn it into a weak item. So the effect of negation is to reverse the logical relationship in the Horn scale, right? So if you say, I ate some of the cookies, the sentence I ate all of the cookies is logically stronger, right? And then you deny it, and then you have I ate all of the cookies, but I didn't eat, sorry, I ate some of the cookies, but I didn't eat all of them. Now, if you have I ate all of the cookies, that's strong, super strong, and there is nothing to cancel. But if you say, if you add a negation, you say I didn't eat all of the cookies, right? Then all, when it combines with negation, becomes weak, becomes weaker. And then it enters in a relationship with some, logically speaking. So not all is entailed by not some, meaning none, and then you negate it, okay? So, and then you get not all, but some. So the take-home message here is that negation behaves exactly like the antecedent of a conditional. So the effect of these contexts, which are called downward entailing, is to reverse the logical relationship between the items of the scale. Therefore, something that was super strong, like exactly 2, becomes weak, and something that was super weak becomes strong. And this is the reason why we have this kind of strange pattern, okay? You know, you can think about this if you want for the rest of your life, but at some time, you know, if you play with these guys a little bit, you will start, like a pattern will emerge, right? And you will start noticing that what I tell you is true. Okay, let's come back to numerals. So if you haven't seen this with your own eyes, believe me, okay? So the idea is that in declaratives, exactly 2 is logically stronger than at least 2. In conditional antecedents, at least 2 is stronger than exactly 2. So if you assume that this is derived through a scalar implicature, and if you have a principle that says that you should derive scalar implicatures when give you a more informative interpretation, then you should not do this here. You should not do that in conditional antecedents, okay? This is a big problem for theory, a big, big problem for theory, especially for the Gricean theory. And if you're gonna read at some point in your life, Kierkegaard and Spector, the grammatical approach of scalar implicature, that's exactly one of the biggest problem of the Gricean apparatus. They call it cracks in the Gricean apparatus, okay? Of course, there are many ways to circumvent this problem, to solve this problem. You might say that these stuff are computed locally, ignoring the overall context, but you know, at the face value, this is an issue. Because you want to have an implicature when it gives you something more informative, but if you do this in downward entailing context, it's going to give you something less informative, violating all the rules of communication that the whole enterprise of Grice was based upon. All right. So the idea is that the entailment patterns affect our way of interpreting numerals. How do we know that? Because there was this nice experiment done by these people that found that if you ask people to give you some judgments about the interpretation of numerals, they would tell you that 2 in this sentence, like John parked 2 cars in the garage and he will park a motorcycle in the courtyard, gets more exactly 2 interpretations in an upward entailing context, or less, fewer, at least n interpretations in this sentence compared to a sentence where 2 was embedded in an antecedent of a conditional, okay? So we know that these entailment patterns affect our way of interpreting numerals, Yeah, and also we did this in a visual world paradigm. And we know that adults tend to optimize the logical strength in interpreting numerals. So they follow this principle of adopt more strength in interpretation when they lead you to a stronger statement, okay? Which can be defined as optimized informativity. But how about children? Do children do the same? Do they use more often exactly N interpretations in contexts where this actually gives you a stronger interpretation? So do they use more exactly interpretation in declaratives compared to downward entailing context? This is exactly what we are going to look at now, okay? All right. So we know that children prefer the exactly N interpretation, right? You should know that as well from this experiment by Wang and Spelke. We have just seen that children can access the at least interpretation with the Goofy experiment. And we know that children are sensitive to entailment by this experiment where they were interpreting disjunction. So what we want to know is to see if this affects their way to interpret numerals. They were of interpreting numerals, okay? So we know that children has a strong preference for exactly N reading. We know they're able to adopt the at least reading, and we know they're sensitive to entailment. So let's put this thing together and let's see what happens with numerals. So to do this, we developed the Kermit's race game test, which is basically a reward task, like many that we have seen in many experiments, like Skordos and Papafragu and so on. Give a coin if they did the right thing. Also sounds like our experiments on indirect scalar implicatures. Right. And then, you know, being inspired by Musolino and the paper we just seen, we also wanted to have a pragmatic boost to elicit at least N interpretations, because we know that children like to stick to the exact interpretation for some reason. So we want to make sure that they had at least an interpretation. So we developed the context of need, right? What we were just talking about with Mike. And also some acting out. So they would be sort of aware of what's going on. And then we had this manipulation of the entailment pattern. So we had numerals embedded in declaratives versus numeral embedded in conditional antecedents. All right. So here's our prediction. If children's ways of interpreting numeral is affected by entailment patterns just as adults' interpretation is, they should employ the same operation to shape numerals interpretation, and they are likely to start out with the same basic semantic representation, okay? So if numerals behave like adults, then it's likely to infer that they have the same competence with respect to numerals, they employ the same operations, and they start out with the same starting point, okay? Whether it's at least, exact, or who knows. All right, so here's the experiment. Sorry guys, let me get some water because my throat is getting dry. Okay, so this is Kermit, okay? Kermit the Frog, quite famous. And he's blindfolded because he suffers from an illness at his eyes. So he wants to organize some races with his friends, the 3 boys that you should be familiar with. And he asks the boys to find the contestants for the races, okay? And the prize is to reward the contestants. So he whispers to this guy what he wants. He whispers to this guy what he wants. And the participant did not hear the whisper, okay? It was like, psst. Good. Then he covers his eyes because he's sick. And the boys bring what they found. So this boy here brings a butterfly, and this boy brings 3 butterflies, and this boy brings a dragonfly. So in the control items, the one that I was mentioning before, Kermit would say, I remember what I told this boy I needed, a dragonfly or a ladybug, okay? And then he utters, if this boy brought me what I need, if this boy brought me a dragonfly, give him a coin. Give coin. If this boy brought me a ladybug, give him a coin. No coin. So this was to make sure that the children would understand the task and would reward when the boy did the right thing and would not reward when the boy didn't do the right thing, okay? So training phase. And then in the critical trials, he would say, I remember what I told this boy I needed, 2 butterflies. If this boy brought me what I need, if this boy brought me 2 butterflies, give him a coin, okay? So if you give a coin to this boy here, it means you interpret 2 as at least 2, okay? And notice that 2 is in a conditional antecedent. And then he would take out the mask and he would say, okay, oh, right, so please take 2 of the butterflies that this boy's brought and put them on the track. No matter whether the participant rewarded this boy with a coin or not, okay? Regardless of the answer, the response, it would just say, take 2 butterflies out of the set and put it on the track. And this would highlight the saliency of the relationship that 2 butterflies is included on 3 butterflies. Cool. Then, they would put stuff on the track, and then the race starts. We would play the race. The participant always won. And yeah, the race is over. And the winner is the red butterfly. Let's take some prizes for the contestants. And the experiment would go on again. Prize trials. Okay. And finally, the contestant get the prizes. Cool. So the experimental design is just like this. We had 8 stories in the upward intake condition, 8 stories in the downward intake condition, 38 children, 14 rejected, which upset elites, 2 control trials, and 1 practice trial, okay? So the control trials are these ones where they have to reward for the butterfly and not reward for the dragonfly. Okay, and we had 8 experimental items. These were in between subject manipulation. So if you were a subject of this experiment, you would only see item in one of the 2 experimental conditions, okay? Right, and the control items could be false items, must not give a coin. We had 10 of them, or true items, which could be a number match. So I'm asking you for 2 butterflies and the boy actually brought 2 butterflies, or an item match, 1 dragonfly, 1 dragonfly. So this is also important to make sure that they understood the meaning of numerals. Although we asked them to count objects at the beginning of experiment, so we also made sure that they actually were CP knowers, okay? Because they were from 3 to 5, so quite young. We also had some 3-year-old kiddos, okay. So the exclusion criteria was if they gave more than 1 reward for the wrong kind of object or more than 1 reward for the wrong number, we would exclude them, okay? Because it means that they did not understand the task very well. All right, so make sure that they understand the task and they have the knowledge of numerals meaning, right? And let's have a look at the experimental items. So this one, in this one it says, I remember what I told you, what I told this boy I needed, 2 butterflies. I think this boy brought me what I need. I think this boy brought me 2 butterflies. Give him a coin if I'm right. So here, in this sentence, 2 occurs under the scope of think, which is an upward entailing context, okay? It's a declarative sentence. If I think I will smoke a Marlboro, it is also true that I will think that I will smoke a cigarette, okay? So although you see that there is a little bit of a conditional here, right? So in the end, give him a coin if I'm right might refer to the sentence, give him a coin if I'm right in saying that he had to bring 2 butterflies. So this is kind of weakening a little bit, but still you had the numerals in an upward entailing context, okay? Now compare this with the downward entailing condition. If this boy brought me what I need, if this boy brought me 2 butterflies, give him a coin. 2 is under a conditional, okay? So Important. Here, 2 is in declarative. I think this boy brought me 2 butterflies. Give him a coin if I'm right. Versus, if this boy brought me 2 butterflies, give him a coin. Okay? So, do you feel this difference? Do you feel that you would answer no in this context, but yes in this context? Or you would answer no in both contexts? Or yes in both contexts? How would you answer? Would any of you always answer no and always say, no, this boy didn't do what I told him to do? Raise your thumb if you would always answer no. Okay. Would you accept what the guy did in this context? Would you give him a coin if he asks this boy to bring 2 butterflies and he brings 3? Alexander, yes. The other people are brain fried, so probably they are undecided. Okay, so I give you the results. So I'm gonna give you now the percent of rewards of give a coin in the experimental items. The items with 3 butterflies when asked for 2, okay? So this is the results. In the declarative, children were super picky. They only gave the reward in 9% of time. In the conditional, they were actually much more rewarding. So they would give the coin in 40% of trial. Still quite low, right? But definitely different than 9. So again, when the item was, if this boy brought me 2 butterflies, give him a coin, they would give him a coin in 40% of trials. If the critical item was, I think this boy brought me 2 butterflies, give him a coin if I'm right, they would almost never give him a coin. Although then we would ask, okay, take 2 butterflies of that set and put them on the track, okay? Right, so then we run some statistics and this is completely significant. So then we concluded that yes, 3 to 5-year-old children's interpretation of numerals is affected by the entailment process of the sentence in the same ways as adults' interpretation is. And children adopt more often the at least an interpretation in conditional antecedents than in declaratives. And you see there is a parallel between adults and children. They do employ the same mechanism to interpret numeral determiners, and these mechanisms are geared to optimize logical strength. And probably they start out with the very same basic meaning as adults. However, the question is, which are these mechanisms? And what is the basic meaning of numerals? And we don't know yet the answer to this question. So there are 2 stories, for instance, right? One story is that the basic meaning is exactly 2. And the other story is that the basic meaning is at least 2. Okay? So along with the story that the basic meaning is exactly 2, you have a pragmatic inference to get the at least 2 meaning, something that I was, yeah. Maria, I noticed your question. Let me answer that in a second, okay? So then this is just what I was telling you before. In this story, you have a pragmatic inference that is weakening the meaning of exactly 2 and give you the meaning of the at least 2, either weakening or adding some sort of weakening operation. And this story is consistent with all the data that we have seen, that even young children like to use the exact meaning a lot, right? Also Musolino's experiment. And the evidence for this, yeah, is many studies showing that children prefer the exact interpretation. But there's another story. There is a Barner story, right? Or the story that this kind of experiment suggests, that the basic meaning is at least 2, and you pragmatically enrich it with some sort of scalar implicature, okay? And this is consistent with the fact that also some of you noticed that numerals seem to form an entailing scale, and seem to be subject to this kind of strengthening. And you can also apply to them this little word only that you can also use with every other scalar item, okay? So, taking stock, and Numerals possess some knowledge about n+1. They treat n+1 as a symbolic quantifier, and the architecture is in place before acquiring the meaning of greater numbers. Part 2, children consistently interpret numerals adopting the exact interpretation, unlike other quantifiers. Part 3, children deal with ambiguity of number words with respect to the logical embedding context in the same ways as adults do. So children interpretation of numerals is sensitive to entailment, just as with adults, okay? And one of the two readings seems to be pragmatically derived. We don't know exactly how, okay? But the idea is that they share the same basic lexical interpretation and pragmatic enrichment operation. So you see, I came to the very same conclusion that Musolino came to, right? Although with a different experiment and, you know, with different, with sort of different results. Okay, so this was kind of crazy, and I'm sorry for frying your brain. Probably if you knew that, you would have chose the other presentation. But yeah, so Maria says, okay, what about think, right? Does think play a role here? Right, good question. So let's go back to our think. So what exactly do you mean, Maria? Do you mean playing a role in suggesting more exactly an interpretation, or playing some other kind of role?
I mean, any role that can play. I don't know. Why did you choose the verb think?
Right. Right. So, you know, the trick is that we had to add some sort of uncertainty in the mind of Kermit, right? Because at the end you get a mismatch between the object he asked for and the object the guy brought. So let's say that he said something like, let me get to the right. Let me say that let's say that he said something like, I'm sure the boy brought me what I need. I'm sure the boy brought me 2 butterflies. Give him a coin if I'm right. It sounds a little bit strange to say that you are sure about something, and then to say, okay, give him a coin if I'm right. So using thinking, right? If anything, what you get is a sort of a weakening effect of the declarative effect, right? So if you say, I think this boy brought me what I need, I think this boy brought me 2 butterflies, you still leave room for some uncertainty. And this uncertainty, if anything, should actually lead you to adopt more, at least an interpretations, right? Because, I mean, we don't really know, but definitely it's not going to give you the effect of strengthening the numeral by itself, because in a way the semantics of thinking is kind of similar, at least to me, to the semantic of the conditional. So in the conditional, you are allowing a possibility that this boy didn't do what he told him to do, right? And also with thinking, you kind of make room for this possibility, right? Do you guys agree with what I'm saying, or you think that actually I'm wrong? You agree? Good. So yeah, so you know, what I would say is that in spite of the presence of the conditional here and of the presence of think, actually we got a quite a big difference between these and the conditional, right? And so, you know, in a way, this extends the kind of results shown by Musolino to this sort of entailment manipulation, and suggests that entailment and numerals interact. Okay. So, any other question? Any other comment? Okay. So I'm glad that our class turned like to explore other creatures other than pure scalar implicatures and pure scope ambiguity. And you see, you know, there is a lot of stuff to investigate, right? A lot of stuff to explain yet, which means that if you're interested in these topics, there is a lot of room for research, a lot of things that previous work, a lot of new questions that previous works actually have generated, rather than addressing them, which is, you know, it's good if you sort of want to start investigating or working on these things at either the theoretical or the experimental level. There is also a lot of room for making bridges between between psycholinguistic investigation and linguistic theory, right? The problem, and this is something that kind of everyone, you know, each one of these guys that we talked about, Stephen Crane, Musolino, Jeff Leeds, were highlighting, and also, you know, Papafragu, Skordos, Jesse Snedeker, all these very, very smart people understood that when you do experiment with children, you have to be very, very, very careful at making the experiment pragmatically felicitous. Because if you fail to do that, you're going to get rubbish out of the data, and then you might actually draw some unwarranted conclusions. Like that, for instance, children did not understand the meaning of the things that you include in your experiment, when in fact they didn't understand the extra-linguistic features of the experiment, the pragmatics of the experiment, okay? So this whole sort of program of making experiments with children more pragmatically felicitous was started from Stephen Crane when he developed the true value judgment task. And then, you know, it was a consistent effort of everyone, like Jesse Snedeker with the cover box task, ourselves with the semantic choice task, and, you know, different people have different strategies, okay? All right, I guess that's enough for today. This time, let me make sure that I don't give you wrong information.